Good morning, grade 11. Now, inshallah, we are going to start a new lesson. Okay. Thanks for your participation. First lesson will be called as instantaneous reaction rates and reaction mechanism. Okay. Can you listen, please?
Section 4, Instantaneous Reaction Rates and Reaction Mechanisms. The slowest step in a sequence of steps determines the rate of the overall chemical reaction.
Okay, so can you read please? Walid, can you read, please? Walid,
read what?
read what? Read what I read.
This okay. Section 4, instantaneous reaction rates and reaction mechanisms. Main idea: the slowest step in a sequence of steps determines the rate of overall chemical reaction.
Okay. After that, the essential questions that you are going to study in this lesson. Listen.
Essential questions. How are instantaneous rates of chemical reactions calculated? What substances and steps are involved in a reaction mechanism? How is the instantaneous rate of a complex reaction related to its reaction mechanism?
It's okay. Can you read please again? Walid.
How are instantaneous rates of chemical reactions calculated? What
It's
substances
okay.
and
That's
steps?
enough, Hussein. Can you read? Hussein? Good morning, Hussein. Okay. Can you? Yes. Can you read second and third question?
How is the instantaneous rate of a complex reaction related to its reaction mechanism?
Okay, number 3.
I just read 3, so I will read 2. What substances and steps are involved in a reaction mechanism?
That's okay. Thanks, Hussein.
Mechanism.
After this, the vocab that we studied before, decomposition reaction. Okay, who can answer me? What about decomposition reaction? What about? Yes, yes, Hussein.
When the reactant is split into products.
It's okay. Walid, do you have any information?
Maybe decomposition reaction is like a chemical substance breaking apart.
Yeah, good. Decomposition, if you remember that decomposition reaction means what? Means if you have a compound as A, B, it's a compound, okay? By its decomposition, okay, by heat, this triangle, simple Z, it will produce A plus P. It's okay? The meaning
Yes.
of decomposition reaction. Understand?
Yes.
Yes.
It's okay. After that, the vocabs that you are going to study. Okay, number 1. Listen, please.
New. Instantaneous rate. Complex reaction. Reaction mechanism. Intermediate. Rate determining step.
Okay, can you read, Walid, first 3?
Instantaneous rate, complex reaction, reaction mechanism, intermediate, rate determining step.
It's okay. Again, Hassan, please. Again, Hassan, please.
Instantaneous rates, complex reaction, reaction mechanism, intermediate, rate determining step.
It's okay, Hassan. Can you don't make mute for yourself? Okay.
Okay.
Okay. to be online at any time. After that, okay, change in H2O2 with time. Okay, this is instantaneous reaction rate. Okay, listen. This is called about what? Okay, this is called about what? Instantaneous reaction rate. This figure shows the concentrated of H2O2 over time during the decomposition reaction, as H2O2 will be decomposed into H2O and O2 evolves up. So it's called decomposition reaction. As I said before, the meaning of decomposition reaction is that any compound can be decomposed by heat or by electricity into simple substance. As this is H2O2, okay, H2O2 per hydrogen oxide, okay. After its decomposition, it will change into H2O, which is cold water, and O2 evolves up. Okay, so this instantaneous rate is the slope of the straight line tend to the curve at the specific time. Okay, this is the instantaneous rate. I have this equation. Okay, after that, instantaneous reaction rate. Okay, instantaneous rate can be calculated if the concentration are known, the temperature is known, and the experimentally determined rate law and specific rate constant as that temperature are known. As 2N2O5, it's a gas state, can be decomposed into 4NO2 gas and O2. Rate equal KN2O5. Okay, rate KN2O5. Okay, and K equals what? K equals 1 times 10 power negative 5. Okay, power negative 5 second minus 1. And N2O5 is equals to 0.350 mole per liter. So this rate equal this number of K, which equals 1 times 10 power negative 5 times N2 concentration of N2O5, which equals to 0.350 mole, equals finally 3.5 times 10 power negative 6 mole per liter times. It's okay, so it's called instantaneous reaction rate. Understand me till now? Any problem? Okay. After that, this example. To calculate instantaneous reaction. The following reaction is first order in H2 and second order in NO with a rate constant of 2.90 times 10 power 2 liter square per mole square times. According to this relation, okay, according to this relation, which equals 2NO gas plus H2 gas to produce N2O gas plus H2O gas. Calculate the instantaneous rate with the reactant concentration R. NO equal this, mole, and H2 equal this number. Okay, how can we calculate it? First, the rate law can be expressed by rate equal K NO2 H2. Okay, so Therefore, the instantaneous reaction rate can be determined, okay, by inserting reactant concentration and the specific rate constant into the rate law equation as what? Known and unknown. Known, NO, this number, H2, this number, and K equals this number. But unknown is the rate, mole per liter times time. So how can we calculate it? First, state the rate law. That rate equal K NO to H2. After that, solution. Substitute K, which equals to 2.90 times 10 power 2, and the concentration of NO, this number, while concentration of H2, this number. So rate equals 2.90 times 10 power 2 times number of NO concentration times number of H concentration. Will be what? Multiply the numbers and units. Rate will be equal to 4.64 times 10 power negative 6 mole per liter times 7. So units in the calculation cancel to give mole per liter times 7, which is a common unit for reaction rate, a magnitude of approximately 10 power negative 6 mole per liter times second fits with the quantities give and the rate law equation. The answer is correctly expressed with 3 sign questioned figures. It's okay, understand me? Any problem till now? Walid, Hussein, any problem?
No.
Okay. After that, listen please to this.
Reaction mechanisms. A reaction mechanism is the complete sequence of elementary steps that makes up a complex reaction. Most chemical reactions consist of sequences of 2 or simpler reactions. Each step is called an elementary step. A complex reaction contains 2 or more elementary steps. An intermediate is a substance produced in one of the elementary steps and consumed in a subsequent elementary step. Intermediates do not appear in the net chemical equation.
Okay, understand this? So it's called reaction mechanism. Reaction mechanism that show about the complete sequence of elementary steps that makes up complex reaction. So it's called about what? It explained the sequence of elementary steps that makes up complex reaction. Most chemical reaction consist of sequence of 2 or more simple reaction. Sure, 2 or more simple reaction. Each step is called an elementary step. Each step inside any chemical reaction called what? Called elementary step. A complex reaction contains 2 or more elementary steps. This is complex one. But an intermediate is a substance produced in one of the elementary steps and consumed in subsequent element step. So it's called what? It's called an intermediate. So it's a substance produced in one of the elementary steps and consumed in a subsequent elementary step. Intermediates do not appear in the net chemical equation. Take care from this information that intermediate don't appear, okay, in the net chemical equation. So, this example, okay, reaction of chlorine catalyzed the composition of ozone. Okay, this is chlorine. Okay, this is what? This is chlorine. Okay, this is ozone gas. that consists of what's the structure of ozone gas? Who can answer me, guys? What about the structure of ozone gas?
O3.
Good. O3 consists of 3 oxygen atoms. Okay, so one chlorine atom, okay, will make a reaction with one oxygen atom to produce ClO, okay, and O2 is produced from this reaction. So Cl plus O3 produce ClO plus O2. Okay, so ozone gas O3 consists of what? O3, the mechanism of formation of ozone gas by reaction of 2 oxygen atoms, okay, 2 oxygen atoms with, which called oxygen molecule, plus 1 free oxygen atom. So oxygen molecule plus free oxygen atom to produce ozone gas. After that, ClO make a reaction with the free oxygen gas, okay, to produce what? To produce Cl only plus oxygen molecule. So it's reaction mechanism. It's reaction mechanism that explains steps by which reaction will be ended, step by step, called what? Called reaction mechanism. Okay, understand it? Any problem till now? Okay,
No.
okay. After that, this is the energy of reaction. And this is the energy that will be increased. Okay, this is a product. Finally, reactants as 2NO plus H2. Okay, pass with activated complex, then intermediate, then activated complex again, then intermediate, activated complex, and by the ending of reaction will produce N2 plus 2H2O is a product. So it's called reaction progress, or the steps of this equation, step by step. Okay, so this equation has intermediate processes. Okay, intermediate processes, but at the end, we have the product which is produced by this reaction. Okay, so this is the energy of reaction that explains reaction mechanism of reaction between 2NO plus 2H2 to produce N2 plus 2H2O. Okay, after that, listen please to mechanism, to reaction mechanism. Listen.
Reaction mechanisms. Every complex reaction has one elementary step that is slower than the others. The slowest elementary step in a complex reaction is called the rate-determining step.
So every complex reaction has one elementary step that is slower than the other, okay? But the slowest elementary step in a complex reaction is called what? Is called the rate-determining step. Rate-determining step. So this is the session today, okay, to review the essential questions that we studied at this session.
Review. Essential questions. How are instantaneous rates of chemical reactions calculated? What substances and steps are involved in a reaction mechanism? How is the instantaneous rate of a complex reaction related to its reaction mechanism? Vocabulary. Instantaneous rate. Complex reaction. Reaction mechanism. Intermediate. Rate determining step.
It's okay. So this is the question that we explained at this session. This is vocab that we studied in this session. Okay. Now we are going to move to our macro health site on this. Okay. So this is animation video.
For simple reactions, for example those between atoms, the frequency factor A in the Arrhenius equation can be equated with the frequency of collisions between reacting species. However, for more complex reactions, the orientation factor must also be considered. More specifically, how are reacting molecules oriented relative to each other when they collide? The carefully studied reaction between potassium atoms and metal iodide, CH3I, to form potassium iodide, and a metal radical, CH3, illustrates the importance of the orientation of the collision. Click on Correct or Incorrect Orientation of Collision. This reaction is most favorable when the potassium atom collides head-on with the iodine atom in CH3I. In this reaction simulation, the potassium atom collided with one of the hydrogen atoms of CH3I. With this collision orientation, few or no products are formed. This reaction is most favorable when the potassium atom collides head-on with the iodine atom in CH3I. Otherwise, few or no products are formed.
Understand all of this? Guys, understand this well?
Yes.
It's okay. Now, inshallah, we are going to go to this question as in the session. Okay. Walid, can you read the first question?
Which of the following is the theory that said that atoms, molecules, and ions must collide for a chemical reaction to occur? Collision theory.
What is the best answer? Collision.
Theory.
Number A. It's okay.
Yes.
Number 2, Hussein.
A chemical A breaks down into chemical B at T equals 0. A equals 0.1 m. At T equals 10 seconds. And then A equals 0.075 m. What's the average reaction rate?
Yeah, what is the average reaction?
Shows that. So we multiply the time with the chemical A.
Multiplying or making plus to get the average.
Ahin is the average.
Yeah, need a hint?
Yes, hint, please.
Do you see this hint?
No.
What is the change in the concentration per second? What is the change in the concentration per second?
The change is 0.025 is the difference.
It's okay. Al-Walid, number 3.
How much time has passed when 5 mole have reacted at an average rate of 0.5?
How much time?
1 second. A.
Number A. Okay, Sin.
What's the name of the unstable molecule formed during the collision of A2 and B2?
A2 and B2. Called what?
Activated complex. Or no. The atomic molecule or activated complex.
Okay, what's your choice?
I think activated complex.
You think this? Okay, but I didn't think this. We are going to know the best answer at the end. Okay, Walid, activation energy is what? Walid. Walid, please don't make mute for yourself.
Sorry, I clicked it by accident.
Okay.
Activation energy is energy released by chemical reaction. No. Energy released by chemical reaction. Yes, A.
Okay, it's number A. It's okay. Now we are going to know the best answer. Grade test. Okay. First question, yes. As Walid said, collision theory. Number 2, yes, as Hussein said, this. Number 3, false, as Walid said. Number 4, yes, as Hussein said, called activated complex. Number 5, false, it will be the energy reacting particles must have to form the activated complex. It's okay, understand, guys?
Yes.
Thanks for your participation now. Okay, and I think enjoy your time. Okay, enjoy your day. Thanks, my friends. Thanks, guys.
Okay.
Okay,
Welcome.
welcome, guys.